Okay, this is a hopefully quick review of the answer key for your test review. The first one says, if you draw a green marble 41 out of 50 times, what's the experimental probability that the next marble you draw will be green? So if you've already drawn it 41 out of 50 times, 41 divided by 50 is 0.82. Move your decimal 2 places to the right, 82%. Or you can say 41 out of 50 is what out of 100 times? Multiply by 2, multiply by 2, 82%. Now the next one says, based on this experiment, they have landed on 9 out of, this is 50 times if you add it up. 8, 6 is 14, plus 11 is 25, plus 7 is 32, plus 18 is 50. So if they've landed 9 out of 50 times already, same type of question as above, that would be 18 out of 100, or 18%. Okay, now this one, you roll a 6-sided number cube, you flip a coin. What is the probability of rolling a number less than 2 and flipping tails? Well, there's only one number less than 2 because it doesn't say less than or equal to, it just says less than 2. Sorry, it's moving. So that's 1 out of 6 because there's only one number less than 2 out of a 6-sided die. Flipping tails is 1 out of 2. So you end up with 1/12. Multiply the probability of the first event times the probability of the second event. The number of students in your school who have visited an art museum. You survey 20 students in the art club. 17 have visited a museum and 3 have not. So you conclude that 85% of the students in your school have visited an art museum. Is your conclusion valid? Why or why not? Okay, so remember, in order for a survey to be valid, you cannot survey a homogeneous group, or you cannot survey a group of like-minded people. So if you're wanting to know who went to an art museum, art club students are obviously into art, so they are more likely than other students in your school to have visited an art museum. So this is not valid because all students, whoops, it's hard to write while looking at the screen. All students are in art club. Okay, so the next page says you want to know the average height of your 3 closest friends. Should you survey the population or a sample? Okay, we normally think a population is something very large, but in this case, you only want to know about your 3 closest friends. That's your entire population. So if your entire population were the state of Oklahoma, you would want to do a sample, but your entire population here is just your 3 closest friends. So just do the population because it's only 3 people. This one, okay, so this is where we have to make the chart, and you're gonna draw a first draw and a second draw. And then I'll do the other ones over here, a first draw and a second draw. And we have -2, -1. These are your options on your first draw, 1 and 2. And for your second draw, because you replaced that tile, you have the same options, -2, -1, 1 and 2, -2, -1, 1 and 2, -2, -1, 1 and 2, -2, -1, 1 and 2. So now we have to decide of these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 possible outcomes, because I could get -2, -2, -2, 1, -2, -1, -2, 2. That's 4 possible outcomes for each first straw, so that's 16 total. So now I have to go through and figure out, of these, which is going to give me a number less than 0. So I literally have to say -2 divided by -1 is a positive 1. That won't work. -2 divided by -1 is a positive 2. That won't work. -2 divided by 1 is a -2. -2 divided by 2 is a -1. So I've got 2 options there. A negative divided by a negative, automatically a positive. Negative divided by a negative, automatically a positive. This would give me -1 and -1/2. So far I have 4. Here we have a positive divided by a positive is obviously going to be a positive, and a positive divided by a positive is a positive. 1 divided by -2 is -2. 1 divided by -1 is -1, so that's 2 more options. So you'll notice there's 2 for each set. Get rid of those positives, because a positive divided by anything positive is going to be positive. Here we have -1 and -1/2. So I ended up with 8 out of 16, which is 50%. Okay, you randomly guess the correct answer of a multiplication question 1/4 of the time. So if you can randomly guess the correct answer 1/4 of the time, is it certain that you're going to get the correct answer? Likely, equally likely, unlikely, or impossible? Well, you're only going to get it right 1/4 of the time. Well, that's not never, so that's not impossible. But it's not 50%, which would be equally likely, and it's certainly not likely or certain, so it has to be unlikely. And then describe the likelihood of this event. There's a 95% chance that school will not be canceled tomorrow. So what is the likelihood that school will not be canceled? Likely. It's not certain that school will not be canceled, but there's a 95% chance that it will not be canceled, so it is likely that it will not be canceled. Okay, now this one. This says, what is the probability of rolling a 2 based on this experiment? Okay, so they rolled a 2 6 times. Out of 8 plus 6 is 14. 14 and 9 is 25, plus 11 is 36, plus 9 is 45, 36 plus 9 is 45, and then 7, that's not right, hold on, I'm trying to go too fast in my head. 9 and 11, is that right? Yeah, 20, 9 and 7, 16. So again, this is 50, okay? The probability of a 2 would be 6 out of 50, which would be the same as 12 out of 100, or 12%. An even number would be, they got 6 times a 2, 11 times a 4, and 7 times as a 6. So 6, 11, and 7. So 6 plus 11 plus 7, 24 times. Out of the 50 times that they did it, that's the same as 48 out of 100, or 48%. Probability of rolling less than 5. So less than does not include 5. So it would have to be 8 plus 6, which is 14, plus 9, which is 23, plus 11, which is 34. So 34 out of 50 is 68 out of 100, or 68%. The probability of rolling a 1 or a 6. So 1 was 8, 6 was 7. It's 15 out of 50, 30 out of 100, 30%. Okay, you checked 20 flashlights, 5 do not work. What is the experimental probability that a flashlight that you choose will be defective? It's 5 out of 20, 1 out of 4, 25%. Okay, because 1/4 is the same as 25%. Okay, this one was, oh, I didn't write down my own numbers, did I? We'll come back to this one because I've got to go back and get the colors for that one, so we'll come back. Okay, I'm going to have you skip this one. We'll go over that one together in class, but for now, skip it. Okay, now we're going to come to this one. Experimental probability of rolling a 5. 5 is 19 out of 13 and 16, which is 29, plus 15, which is 44, plus 17, which is 61, plus 19, which is 80, plus 20, which is 100. So if it's 19 out of 100, that's easy, 19%. 2 or 6, 16 plus 20 is 36 out of 100, or 36%. At least a 3, so that would include 3, so 3, 4, 5, 6, so 15 plus 17 plus 19 plus 20, that's 71 out of 100, so 71%. The experimental probability of rolling a number less than or equal to 4, so 4 or less, again, is going to be 17 and 15, which is 32. 32 plus 16, 48 plus 13, 61. 61 out of 100, or 61%. Okay, and then this one was, I think, blue, red, yellow, and that's for these problems. The probability of landing on an odd, flipping heads, well, heads is 1 out of 2, and landing on red. So there was only one red space, so that's 1 out of 3, but there were 2 odd spaces, 2 and 3, so that's 2 out of 3. Multiply those together. 2 times 1 times 1 is 2. 3 times 2 is 6. 6 times 3 is 18. 2 out of 18. Do you see what's going to happen here? It's just going to keep repeating. So we're going to end up with 11.1 or 11%. Okay, now here we have landing on 2. There's only 1 out of 3. Flipping tails, 1 out of 3. Oh, sorry. 1 out of 2. And then landing on 2 again, 1 out of 3. So that's 1 out of 18. So if 2 out of 18 was 11%, 1 out of 18 should be 5%. Yeah, that'd be 90. And then it wouldn't be enough to round up. So, sorry, that's messy. 5%. I don't want to use my calculator on my phone because it will mess up our video. Probability of landing on 1 or 2. So that'd be 2 out of 3. Flipping heads, 1 out of 2. Landing on a 3, 1 out of 3. So again, we end up with 2 out of 18, which we decided was 11%. Okay, you want to estimate the number of people in a town who think the park needs new playground equipment. You survey every 5th person who enters with a child. Is the sample biased or unbiased? Well, it's biased because people at the park with a child are more likely to want playground equipment. Whereas if you were to survey someone who just came to the park to take pictures, or they just came to the park to read a book, they aren't going to care so much about playground equipment, likely, that they won't care as much about playground equipment, so they might be less likely to want that. This one is, your town has a ban on skateboarding, and they want to overturn, this group of people wants to overturn the ban. Describe how they could conduct a survey so the sample's biased toward overturning it. So if you want to find people that want to overturn a skateboard ban, how can we find a biased group of people who are going to be likely to want that? Survey people who skateboard. Hang out outside of a skateboard shop. Survey people who are going into a skateboard shop. They're likely more skateboarders or for skateboarding and likely to approve the ban. Survey people who are carrying a skateboard through a park instead of riding it. They're probably going to wish they could ride it. So target people who skateboard or who are carrying skateboards rather than just random people. All right, product using exponents. So we have 1, 2, 3, 4, 5. We have the number 3 is our base, 5 times 3 to the power 5. Now we have -6, and remember that has to go in parentheses because that negative is on both of these squared. -1/2, 3 times. Again, that has to go in parentheses to show that that negative is with each one. Here we have pi times pi times pi times pi times pi. Pi to the 5th times r times r. Radius times radius, radius squared. Here's 4, 3 times y, 2 times. Now this one, the 7 is outside, so it doesn't need to go in parentheses with the 7s. 1, 2, 3, 4, 5, 6, -7 to the 6th. Again, it doesn't have to go in parentheses with the 7 because it's only out front. It's not with every single 7. This one, however, is with every single t. So that parentheses kind of like holds it with it. 1, 2, 3, 4, 5, -t to the 5th. 5 squared. Evaluate this expression. 25. Here we have negative 11 to the third. That negative isn't with it every time, so it's going to stay. 11 times 11 is 121 times 11. Oh, sorry. 2, 1, placeholder 1, 2, 1. Negative 1331. Negative 1 6 times. So if you keep multiplying 1 times 1 times 1 times 1 to 1, you're going to end up with 1. And we're multiplying a negative 6 times. So the negative times the negatives make a positive. Another negative times a negative makes a positive. Another negative times a negative makes a positive. So your answer's positive. Here we have negative on the outside. So my answer is going to be negative. 1/9 times 1/9 times 1/9. And here we have 1 over 9 times 9 is 81. 1 over 729. Negative 1 over 729. Prime factorization of 225 using exponents. 5 and 45. 5 and 9. 3 and 3. These are those factor trees from 6th grade math. So we're going to end up with 3 times 3 times 5 times 5 equals 3 squared times 5 squared. $675. So that's going to be 5. We know it's divisible by 5 because it ends in a 5. 675 and 5. $135. 135 can be divided by 5 again. So we end up with 3 times 3 times 3 times 5 times 5. 3 to the power of 3 times 5 squared. Okay, now we have to follow PEMDAS. 2 to the power of 3 is 8. Take care of that first. Now I do multiplication first. 5 plus 3 times 8 is 24 is 29. Negative 3 times negative 3 is 9. Takes care of that. 7 times 9 is 63. 2 plus 63 is 65. 13 squared minus 12 squared. So 13 squared is 13 times 13. $169 minus 12 squared is 144. Take care of your parentheses. Five to the power of 3 is 125. Seven plus 125 is 132. Yeah. 1/2 of 132, or 1/2 times 132. So 132 divided by 2. 66. 9 squared is 81. Minus 15 times 2 and then divided by 17. So we end up with, do your 15 times 2 first. So that's 30. 81 minus 30 is 51. Divided by 17. And 17 times 3 should give us 51. So that would be 3. This is a power raised to a power. 6 to the 4 times 2. When you have a power raised to the power inside and outside, you multiply them together. 6 to the power of 8. You can leave these in exponent form without finding what 6 to the power of 8 is. This is negative 8. It's telling me to multiply. The base is the same, so that's the same as 3 plus 4. When it tells you to multiply and you have the same base, add the exponents. Again, same base, telling me to multiply, add the exponents. Here we have negative 3, 2 to the 4th. So negative 3 to the power of 2 to the power of 4. A power to a power, 2 times 4 is 8. 5 to the 4th to the 3rd, power to a power. 4 times 3 is 12. Sorry, quit doing those. Okay. This is same base, multiplying, so add the powers. That's like 6 plus 1. That h with nothing is h to the power of 1. H to the 7th. A power raised to a power again. B to the 12 times 3, or B to the 36th. Same bases again. Always check to make sure you have the same base. To the 2 plus 6 is 2/3 to the power of 8. And here you have a power raised to a power again. 3.8. And these parentheses matter. So 3 times 8, or 3 times 12, I'm sorry, to the 36th. Okay. All right, here we go. This one, we need to distribute that 12. So this is r to the 12th, t to the 12th. Same here, distribute that 7. 4 to the 7th, y to the 7th. Distribute that 3. Negative 3/4 to the 3rd, p to the 3rd. You can put your times, you don't have to. Okay, this is same base telling me to divide, so we subtract. This is the same as 7 to the 9 minus 6, or 7 to the 3rd. Negative 4.5 to the 6 minus 2. So that's negative 4.5 to the 4th. M to the 10 minus 5. M to the 5th. Now here we have sum to multiply and then divide. So let's take care of this top. This is 7 to the 5 plus 3 over 7 to the 2nd. 7 to the 8th over 7 squared is 7 to the 8 minus 2. Oops, sorry, 7 to the 6th. Okay, so we have to add these before we can do the subtraction. So we have to do the multiplication before the division. So this is the same as pi to the 30th over pi to the 18 plus 4. Pi to the 30th over pi to the 22nd is the same as pi to the 30 minus 22, pi to the 8th. Negative 2 in parentheses to the negative 8 plus 8. So that's negative 2 to the 0, and any number other than 0 to the 0 power is 1. 0 to the 0 is undefined. but any other number to the 0 is 1. Okay, this is 6 to the negative 2. I have to make this exponent positive, so I pretend like this is a fraction. I take the base and the negative exponent, bring it to the bottom. So I have 1 over 6 squared, which is 1 over 36. For the test, you can either leave it like this or work it out like this. If it's an easy one to do, I would go ahead and just work it out. If not, like these numbers up here that really, or on the page before, the bigger ones, you don't have to work them out. 158 to the 0 power, anything to the 0 other than 1, or other than 0 is 1. Here we have a negative, or no, we have a 0 minus, what am I thinking? Sorry, 1 minus 2. So I'm going to have negative 3 to the 1 minus 2, which is going to give me the negative power. Negative 3 to the 1 minus 2 is negative 1. So now I'm going to have to pretend like this is a fraction, bring it to the bottom, 1 over negative 3. To now the positive 1, or just 1 over negative 3. And here is different bases, so I cannot do the telling me to multiply so we add because the bases are different, but what I do have to do is get rid of this negative exponent. So we're going to bring it to the bottom, and we'll have a to the 7th over 8 squared, which is a to the 7th over 64. Sorry, that kind of looks like a 9. All right, last page. No, not last page. Close, well, last page for most of us. Okay. 5b to the power of 2 over b to the negative 3. So we can take this b to the negative 2, bring it down, this b to the negative 3, and bring it up. So this would now be 5 times b to the 3rd over b squared. See, that 5 stays because it didn't have anything to do with that negative exponent. And this is now 5 to the b to the 3 minus 2, or 5b to the 1st, or just 5b. Okay, 3 times 4 is 12. This is d to the negative 4 plus d to the 4. Now, you could make this a fraction and bring this one to the bottom, or because they're the same bases, we could just say negative 4 plus 4. And d to the minus 4 plus 4 is d to the 0. So 12 d to the 0, which is 12 times 1, which is just 12. And this one is m to the negative 2 into the 3rd. See, I can't just combine them because the bases are different. So I'm going to take that negative exponent with its base and bring it to the bottom. And I'm going to end up with n to the 3rd m squared. Okay, for scientific notation, when we have a number in standard form, we need to change it so that we end up with one non-zero, a decimal, and then my other non-zeros, could be more than one, times 10, it's always 10, to the power of whatever you would need to get back to your original number. So for example, in this one, right now my decimal's here. I'm going to move my didn't mean to do that. I'm going to move my decimals so it goes 1, 2, 3, 4, 5, 6, 7. So now it's going to be here because I have one non-zero and the other non-zero. 7.5 times 10. From here, I would need to go back 7 to the right. So because it's 7 to the right, it's positive 7. So go from where you moved it, how do you get back to your original number? If it's right, it's positive. If you would have to go left to get back to your original number, it'd be negative. Here's my decimal. I'm going to go 1, 2, 3, 8. and I don't need to do the 0.0 because I'm only focused on non-zeros, times 10 to the 1, 2, 3 third. Here I would have to move it 1, 2, 3, 4, 5. So it's 6.75 times 10 to the, now from 6.75, I'd have to go left. 1, 2, 3, 4, 5. Negative 5. Here I have 1, 2, 3, 4, 5, 6, 7. 1.2 times 10 and go back right. 1, 2, 3, 4, 5, 6, 7. Oh, sorry, 1.23 times 10 to the 7th. And then this one we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'd end up with 4.5 times 10 to the, I'd have to go back to the left 10, so negative 10. Now from here, I start with the number 1.23. It's telling me to move my decimal to the right 6. 1, 2, 3, 4, 5, 6. Fill in these little eggs in your empty egg carton, so I think of it. And then if you would please rewrite it for me, 1, 2, 3, 0, 0, 0, 0. That way I know that you know where those commas go. Okay. This one's telling me to go left 2. I'm already at 4.3. If I go left 2, I'm at 0.043. This one's telling me to start right here at 2 and go left negative 12. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's a lot of little zeros. It's 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And your 2. And then this one is 3.81 to the negative 6. 1, 2, 3, 4, 5, 6. 0.00000381. All right, I will go back and do a quick video for the ones with the colors. I need to go get my computer and see what those colors were because I didn't write them down when you wrote them down. And then for the honors review, there's about 6 more problems and I'll do a separate video for that.